Okay. Do you want to put it on the table for? Okay. So sorry for the delay, guys. Basically, what we built out was just kind of like a niche use case when it comes to investigations, specifically fraud, liquidations, when you're dealing with people trying to hide assets,
Oh,
shell companies.
one second. What's the name of this project?
We didn't come up with one.
Oh, okay. Just take a stab at it. Give us a name.
uh, I don't know.
Sizzler,
Nebula Investigations.
McDonald's. Okay.
um,
Nebula
sure.
Investigations. Okay,
And so just to set some context on the stage, what you're seeing, or on the screen, what you're seeing, when you do investigation or you get documents in discovery, sometimes it's like millions of documents. It could be text files, emails, PDFs, images, whatever. And this is just like an open source from, well, we won't get into it, but it's online, but whatever. And basically this document here is an example of like a 10-page PDF that just basically highlights, hey, these are all the assets this person owns, and it's actually layered 3 times. You know, this company owns this company, which owns this company. So you as an analyst, when you're going through, or a lawyer, assistant, whatever, going through, you are manually tasked to review all these documents, and there's a cost per document. You know, probably about $1 a document at least. And then on top of that, you have to deal with, okay, if you've noticed, the first 2 boxes stay the same. This trust owns this holding company, but then the third one in each one is a different one. So what you ultimately are going to create is like a parent flowchart of like 1, 1, and then like 10 at the bottom. And so what we built out instead was, how can you ingest these images to look for, first off the bat, you don't know what you're looking for, but if you want to say, hey, I have a gist or a theory that there's shell companies somewhere, like, go tell me what documents include images that look like hierarchical ownership structures. Find those documents, and then when you put them into this essentially like enrichment pipeline, what we did is, do you want to show you want to go to this text or the code, sorry. Basically what, I'll let you describe it now.
So to explain how we effectively got the entire parsing done, we took the PDF file, which you just saw, and we broke every page into an image. And from breaking into an image, we had like a large vision model, and we chose 4.0, GPT 4.0 for our use case. We had it analyze every image for a couple of things, right? First, we were like, take a look at this image and tell me, is there any graph, is there any chart, organizational chart, hierarchy, anything contained in that image? If it's a yes, let's go for analysis. And what do we do in analysis? We effectively take every page that shows some relationship-based information and convert that into a set of database queries or relationship queries where you can onboard it into a relationship-based database like Neo4j. But here's the fun part. It's not just the queries which we generate. We also go and generate a reasoning for each set of queries we do. And actually, it's more apt to say the reasoning is generated first, where the LLM or the vision model here explains what it is seeing. And from that explanation, it proceeds to generate your Neo4j queries. And you can see, you can just highlight the reasoning part. Yeah. Yep, that one. So you see there, before the queries, you see a lot of pre-reasoning that happened where the image, the hierarchy is explained in a really, really detailed manner. But then we actually have the queries that are generated. We take that data and we onboard it onto Neo4j, which is our DB slash, temporary hackathon visualizer or UI, where you get to see that PDF information perfectly rendered like that. So all of that information contained in those PDFs, page by page relevant, has been smartly extracted, relationships have been quantified, and you also onboarded. And and the best part, it's not just that. If you click on them, you're going to see like it has all the metadata. Something which we're doing is, this is perfectly lossless. There is no data in an image, or at least best case effort here, what we can do in a short period of time. We're trying to see everything which we can extract, where of course every node has a name, but we also try to see how much metadata can we associate with each thing. Like there, if you see in that particular relationship, we are seeing one company owns another, but what's the percentage? So that's 100%. And that is not just meta context, that is queryable, indexable. You can run queries on it. You can do a bunch of analysis on it as well. So effectively meaning now we have this massive outward expanding graph which not only shows you what is there in your documents, but also lets you search, summarize, and it keeps going upwards. And my favorite part of the entire tool which we built isn't what we have today. It's more of where this can go, right? Because the most simplest thing, we can overlay a simple, natural language search, which has been so well tried and tested, where instead of searching this database through like Neo4j queries, which we'll see in a minute, you can type in a question. You can be like, tell me who owns this particular corporation, or who is this person, or what are the emails they've been sending. And you get very concise answers, making the investigation process super, super simple, right? But in lieu of that, given we didn't have time to build out a full natural language search, we can run a smaller Neo4j search, and that'll show you like, can we run a search on that just to like search an entity?
Hey,
also
hey,
why
hey,
this is-
come on, Rob.
But also
Like,
why this is
give
really
everybody
useful.
a fair chance here.
Last bit is you can upload a screenshot of this to like ChatGPT and try and be like, okay, summarize this for me. Sometimes it'll get it right. Sometimes depending on the image quality, it will get the names wrong or whatever. But as you're investigating and you need these pivot points, you have to have everything as a unique entity node, machine readable. So either when you're, scripting your processes or shooting, like when you're trying to automate this, because you deal with millions of these documents, this is kind of the format you need to have it in visually from an investigator's perspective, so you don't have to manually remake the graph as I've been doing in Multigo a billion times, or now you can integrate it into other queries or filter it in. You found a new name, run it through your original database, pivot off of that, and so it's just easier pivoting. I think that's it. Sorry for the delay.
I do have a quick question. So like, how do you handle new information? So for example, if it has a structure and then let's say, later down in the document, oh, that was the old structure, this is the new structure. How do you sort of deal with that?
So in this example, what we've done is we expect this HF trust, it's going to keep evidencing itself over and over again. Everything's new information. So it's a upsert, essentially. So insert and update. So in any metadata that is gathered is added.
So you're making that the assumption is further down the document is always newer information than at the front of the document.
The current code is written that way.
Yeah. Hey, I'm a judge. I gotta like point out. I gotta ask.
But what we did is specifically though is all new metadata found is added to the object.
Yeah.
But our use case is simply to produce the ownership graph. So what you see here is we can query only for owners on whatever the first user interface will be. And because it's on a graph database, we can make any user interface we choose rapidly using the other tools we've seen today.
Okay, so clearly Harvey.ai will be purchasing this company. Is that right? Okay, awesome. Thank you.